Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we will derive the length equation. We can also say that the length formula. The length equation is a precise mathematical relationship between the object distance that will be represented by DO, the image distance that will be represented by DI, and the focal length that will be represented by small f. So here the mathematical form of the length equation, that is 1 by f is equal to 1 by di plus 1 by do. Now here we will derive that how can we obtain by using the convex lens. This formula is accurate only if the thickness of the lens is small compared to its diameter. So the length equation can be derived by referring the figure, which shows the image produced by a convex lens along with the O and A rays that locate the image. So in this figure A, the ray hits the lens at its midpoint. This ray is called O ray, because it is passing through the optical center O, where the principal axis is the normal to the lens. As a result, the ray refracts at an angle theta below the principal axis, that is equal to its incident angle theta above the axis. Therefore, the two green triangles in this diagram are similar. You can also say that the two triangles, that is triangle AOB and triangle A complement OB complement, are considered similar, from which it follows that the ratios of the equivalent sides of the similar triangles are equal. We can say that the AB is equal to A complement B complement and OB is equal to OB complement. So here we will take the ratios between them. So as a result, we will get HO divided by minus HI is equal to DO divided by DI. It is very clear from the figure that the distance from the optical center O and the object is represented by DO, whereas the distance between the O and the B complement, means lens and the image, is called the image distance, that will be represented by DI. So as a result of the O ray, we will get the first equation. Here the image height is taken negative because the image is inverted. Now from figure B, it is clear that the two yellow triangles in this diagram are also similar, and we obtained these two triangles by A ray, which is parallel to principal axis, and after refraction it will passing through the principal focus. Since they are both right triangles and share the common angles phi here, thus by using the same rule of similar triangles, we get HO divided by minus HI is equal to F divided by DI minus F. Now it is very clear from the figure that the distance from O to F means optical center and principal focus. The distance between them is called the focal length, which is represented by small f. Whereas the distance B complement F will be shown as DI minus F. So as a result of A ray, we will get equation number 2. As it is very clear that the left hand side of both the two equations, equation number 1 and equation number 2, are same. Therefore, we can easily compare these two equations. So comparing equation number 1 and 2, we get DO divided by DI is equal to F divided by DI minus F. Now to isolate F, cross multiply, we get dO di minus f is equal to dif. Here the dO will multiply with the di and f which is enclosed in the bracket. So we will get dO di minus DOF is equal to DIF. Now divide equation number 3 by dO DIF. Then we will get 1 by f minus 1 by di is equal to 1 divided by dO. Now add 1 by di on both sides of the equation. We will get 1 by f minus 1 by di plus 1 by di is equal to 1 by dO plus 1 by di. After that we will get 1 by f is equal to 1 by dO plus 1 by di. This is the Lenz equation that we want to prove, and hence we proved that 1 by f is equal to 1 by dO plus 1 by di. You can also write it like 1 by f is equal to 1 by di plus 1 by dO. This final equation is known as the Lenz formula. I hope you understand everything very clearly. Thanks for listening me. Stay home, stay blessed. Allah Hafiz.